Welcome to another lecture. In this lecture, we'll be doing past papers of IGCSE 0620 Chemistry. The chapter that we'll be dealing today would be reversible reactions and equilibrium. So if you look at the PDF, what I've done is from the last about 2 years, 25 and 24, and few questions from 23 also. So I've taken series of questions from the past papers only. So these questions, they are basically in this chapter, they are of three kinds. In the first kind of question, there will be general reactions. So when I say general reaction, there will be a general equilibrium, for example, in a equation like this, or maybe a equation like this. So these are the general equilibrium equations. So this would be part A, where these general equations would be taken. In part B, what we'll be doing is we'll be specifically dealing with the questions dealing with Haber process. So basically all the questions which can be asked in Haber process, we'll be dealing with that. In the part 3, we'll be doing all the previous year questions which have been asked from contact process. So this is a reversible reactions, if you know, 2SO2 plus O2 SO3. So we'll be doing questions from these. But please remember that all these questions that I'm doing, they are from 0620 past papers only. And for any reference, you can have a look at this. For example, this particular question is from 2025 February March, a theory paper 42. Most of the questions which I have taken are from theory, so that you get the basics right. So first we'll be doing general equilibrium equations. This will be part 1. Then in part 2 we'll be doing sulfur, and in part 3 we'll be doing all ammonia questions. So in ammonia equations, a lot of questions are asked on this equation, the basic core equation of manufacturing of ammonia. Similarly, in a sulfur also, all the questions will be asked at the core from this equation only. And I have made exhaustive notes about this. But what I'll suggest is that you should have, gone through the chapter first. This will be a long lecture. This will take, I think, at least an hour or so, 1 hour, 15 minutes. So I'll have made exhaustive notes also. I'll be discussing these notes in detail. But as I've suggested, it will help you a lot if you have read the chapter. But what I promise you in the beginning is a bit of long introduction. If you go through whole of the lecture and you have understood the concepts, there is no way that you can lose any marks, particularly from this chapter. But there are 1 or 2 conditions. The first condition is that you should have a good understanding of rate of reaction chapter first. So rates of reaction chapter, I have done a detailed lecture on that also, because there are a lot of things that will be asked in this chapter, a lot of questions which will be asked in this question, which will require you basic understanding of rate of reaction chapter also. So after this longish introduction about this longish lecture, let's start. We'll be doing, as I've told you, we'll be starting with the general equations first. We'll be starting with equations like these. Then we'll be starting in the second part, sulfur, third part, ammonia. So let's start. So let's start with the first question. The first question says, reaction between aqueous iron 3 ions Fe3 SCN is reversible. Reversible reaction. The equation for the reaction, this is the equation which is shown. This is a reversible reaction. Equilibrium concentration are identical, mixture appears orange. Okay, so at equilibrium the mixture appears orange. When a few drops of aqueous thiocyanate ions are added to the mixture, a new equilibrium forms. So what you do is you add aqueous thiocyanate ions. Thiocyanate ions, as it is mentioned here, these are the ions that you will be adding to the mixture. How does the color of the mixture change? See, the guiding principle behind whole of this chapter is the Lee Chatelier principle. Now you would have read this in the chapter. Basically, how I understand is basically this principle is a teenager's mood or a teenager's action. This is how I remember this. So how will a teenager behave like? So a teenager has a very typical way of acting. So if the parent says that you have to study, the teenager will not like to study. But if the parent says, okay, go out to play, or don't study, a teenager will act in the opposite direction. So a teenager will always react opposite to what his or her parent is saying. So that in short is a Lee-Chatelier's principle. If you look at the definition, this is how the definition looks like, which would be mentioned in your book. So Lee-Chatelier's principle based on practical observation of many reversible reaction and states that when a change is made to the condition of a system in dynamic equilibrium, the system moves so as to oppose that change. So basically, that is why I'm saying it's a parent-teenager behavior dynamics, that whatever the parent will try to say, the teenager will always try to oppose. Now, this is the principle which is the guiding principle, which is the core principle of whole of this chapter. So you need to, get this first, understand this well. For example, in this case, when you are adding aqueous thiocyanate ions, so what the reaction will try to do is you are increasing the concentration. But like a teenager, the teenager will try to oppose this. You are increasing the concentration, but the teenager will try to decrease it. And how can the reaction decrease the concentration? It can decrease the concentration only if it moves in the forward direction, because in the forward direction, these ions would be consumed. I hope this is making sense. So when these are consumed, the concentration of these ions will increase, and that is why the mixture will get more red in color. So, before you go ahead with this lecture, our guiding principle, you should be very clear of Lee-Chatelier's principle. Try to go through your textbook and try to understand this. In short, this is a equilibrium between teenager, his or her parent. Whatever the parent will do, the teenager will try to oppose. That is how I have understood this principle. Okay, so let's look at the next question. Methanol is manufactured by reaction of hydrogen and carbon monoxide. Equilibrium mixture is produced. State what happens to the concentration of methanol when the reaction is at equilibrium. Explain your answer in terms of rate of forward and reverse reactions. State two advantages of using pressure below 75 atmosphere. Effect of catalyst, effect of temperature. So, basically I'll be spending some time, explaining this question because it's a beautiful question where a lot of things are being discussed. We will be talking about, the question is talking about equilibrium. What is the nature of equilibrium? What do we mean by equilibrium? The question is talking about the effect of pressure. The question is talking about the effect of catalyst. The question is talking about the effect of temperature. So, this is a sort of numerical where, almost full of the chapter and all the effects are being captured. So, I'll be spending some time to explain this. So, I'll start with explaining what is equilibrium. So, for example, if we have a reaction like this, the characteristic of equilibrium. So, this is the equation which is given to us. Now, the question is what happens to the concentration of methanol at equilibrium? So, to understand that, first we need to understand what exactly is the equilibrium. So, what is the meaning of this sign? So, basically what this sign means is, I'll give a rough example and, to make things easier, imagine that this is a railway station. This is a railway station. So, during the day, number of passengers are coming to the railway station, and during the day, lots of trains are leaving the railway station. So, for example, 100 passengers are entering the railway station. So, 100 passengers would be, catching their trains and leaving the railway station. So, this is a sort of dynamic equilibrium. So, to make things simpler, end of the day, you'll have 0 passengers stranded at the railway station. I'm just simplifying the thing so that you understand the concept of equilibrium. So, what I'm trying to tell here is that if you see a reaction like this, hydrogen plus carbon monoxide gives methanol, what is happening is that the forward reaction, hydrogen plus carbon monoxide gives methanol, the rate of forward reaction becomes equal to the rate of the backward reaction, that the methanol is decomposing into hydrogen and carbon monoxide. So it is called a dynamic equilibrium. It is not as if things have become static. No, it is not like that. Both sides of the equation have the same rate of reaction. So that is the first thing that you need to understand, and that is what is mentioned here, the rate of forward and the rate of the decomposition of methanol is the same. Now remember, both the things are happening. So at equilibrium, the rate of forward reaction is equal to the rate of the reverse reaction. So the concentration of methanol remains the same. Now at the equilibrium point, the concentration of hydrogen carbon monoxide and methanol would be same. So you might assume that nothing is happening, but it is not like that. The passengers entering the railway station is equal to the passengers leaving the railway station. So it is not as if you can't assume that nothing is happening at the railway station. That is why I took this example. So it's a dynamic equilibrium. It is not static. So the first thing what they are asking is state what happens to the concentration of methanol when reaction is at equilibrium. As I have told you, it remains same. Explain your answer in terms of rate of forward and reverse reaction. So I hope now this is making sense. Both the reaction, the forward as well as the reverse reaction, they are happening at the same time. So formation of methanol in the forward reaction is equal to the decomposition of methanol in the reverse direction. Now, in lot of questions which we'll be discussing ahead in this past year papers, they'll be asking you about the definition of equilibrium. That what is equilibrium? So I've also mentioned here the definition of equilibrium that you can cram. Better to cram because this is a question which is asked many times as a definition also, and it is better to cram because then you'll remember each and everything about what happens in equilibrium. So chemical equilibrium is a state of reversible reaction in a closed system. So equilibrium can only happen in a closed system. This is another property of chemical equilibrium that you need to remember. So usually in books what they do is that this is considered to be the system and this is the environment. So system is basically the container in which our reaction is taking place. So what you need to remember is that for equilibrium, a closed system is required. A closed system is required. Now, what is a closed system? I have captured that in this Excel. So in closed system, what happens is that matter cannot be exchanged with the surroundings. So no matter can enter or leave the system. But so matter can't be exchanged. But what happens is that energy can leave and enter the system. The definition has been discussed in detail in one of the question ahead. Now compare this with an open system. In an open system, both the matter as well as energy can be exchanged with the surroundings. So a very important thing about equilibrium is that equilibrium can only happen in a closed system where the forward and the reverse reaction occur at equal rates. So chemicalibrium, first important point, it happens in a closed system. Second important point, forward and the reverse reaction, the rates become equal. Third, the concentration of reactant and product remain constant. You have to be very clear when you are writing the definition, and these are the kind of questions which are being asked again and again. You will see in the lecture ahead. So condition required, reaction must be reversible. It should take place in closed system. So it's a reversible reaction. So let me mark this as fourth point. The concentration remain constant. It's a dynamic condition. It's not a static condition. So we have understood about the equilibrium part of the question. Now, if you come to the second question, they are asking something about the pressure. Now, let us look at the question. So they are asking, so I'll erase this because we have discussed this. Now we are discussing the pressure thing. Okay. The reaction is carried out at pressure of 75 atmosphere and temperature of 250 degrees Celsius. State two disadvantages of using a pressure below 75 atmosphere. Now, there's something about pressure that you need to understand, and whenever they are asking anything about pressure, the main thing that you need to understand is look at the number of moles of the. Whenever they ask you anything about the pressure, look for the number of moles on the left hand side of the equilibrium and on the right hand side of the equilibrium. So something plus something forms something plus something. Always look at the number of moles. So for example, in this reaction, if we look closely, the 2 plus 1 is 3. This is a 1. So 2 plus 1 is 3. So on the left hand side, you have 3 moles. And on the right hand side, you have 1 mole. Now, let us look at the effect that pressure will have on this reaction. So if we increase the pressure, as per Le-Chatelier's principle, if you increase the pressure of the system will move in a direction where the effect of increase of pressure is nullified. And if you decrease the pressure, the system will move in a direction where the decrease of pressure is nullified. What I am trying to say is that in this particular condition, if I increase the pressure, the system will try to oppose this increase of pressure. How will the system fight the increase of pressure? It will try to decrease the pressure. So it will try to move in forward direction. Why forward direction? Because see, what is happening is 3 moles are being converted to 1 mole. So if the reaction moves in the forward direction, then less number of moles are being made, and that is why the system will be successful in opposing the increase of pressure. So if we increase the pressure, the system will move in the forward direction. But in this question, if we decrease the pressure, the system will move in a direction which will nullify the decrease in pressure. And that can happen if it moves in the backward direction. Why? Because in the backward direction, 3 moles are being created. Let me another like here. So 3 moles, if the system moves in the backward direction, more number of moles are made, and that is why the decrease in pressure is nullified. Hope this is making sense. So basically, in what the Le-Chatelier principle says is that the system will try to oppose whatever you try to tell it. So there will be a definition something like this, which will be mentioned in your textbook, that Le-Chatelier, based on practical observation of many reversible reaction, states that when a change is made into the condition of a system in dynamic equilibrium, the system moves so as to oppose that change. So now let us look at this. If you pressure of 75 atmosphere and 250 degrees Celsius. So if you have understood the logic, you will see that for this reaction, big 75 atmosphere is a big number. The pressure that we have in our environment is 1 atmosphere. So try to imagine 75 times the pressure of the atmosphere, our atmosphere. So why such a huge amount of pressure is being created for this reaction to take place is because we want the forward reaction, the production of methanol to be more. So that is why high pressure is being used. But now what they are asking is state 2 disadvantages of using a pressure below 75 atmosphere. So now if I use lesser pressure, the first thing, as I have told you, if I use lesser pressure, the reaction will start moving in the backward direction. So as per Le-Chatelier principle, the reaction will move in the reverse direction. So that is the first disadvantage. What would be the second disadvantage? The second disadvantage comes from the rate of reaction chapter. Now, at lower pressure, the rate of reaction will be lower. Why? Because as we have done in the rate of reaction lecture, you can have a look at my rate of lecture reaction also. I have made again a very detailed video on rate of reaction. So as we decrease the pressure, so for example, if this was the pressure of the system and I decrease the pressure, the number of successful collisions for a reaction to take place will decrease. So the first disadvantage is that as per Le-Chatelier principle, the equilibrium will shift in the backward direction. The second disadvantage will be the rate of reaction will be lower. Why? Because number of collisions would be lesser. So that is what is mentioned here. That is what is mentioned here. That lower yield of methanol, that this comes from Le-Chatelier principle. Lower rate of reaction, lower pressure in fewer gas per unit volume, fewer effective collisions. So the effective collisions are more. So methanol is formed more slowly. Okay, now let's So we have done the second thing that this question was talking about is pressure. We have discussed in detail pressure also. And that is why I was saying that this is a very good question because most of the things are captured in this question that you will be doing in the next hour or so in this particular reaction. So that is why I took some time to explain this in detail. Okay. Now they are asking catalyst is added. Now again, what you need to understand fundamentally about the role of catalyst is, again, this has a the foundation is from the rate of reaction chapter. Now what a catalyst will do is catalyst will bring the equilibrium faster. So let us assume that the equilibrium takes 5 minutes to reach, but if you add a catalyst, the equilibrium would be reached in 2 minutes. So the only thing that a catalyst does is it brings the equilibrium earlier. So effect on the concentration of methanol and equilibrium. So the so the role of catalyst is brings equilibrium faster. But does it affect the concentration of the product which is formed? No, it doesn't affect the concentration at all. It just brings the equilibrium faster. That's it. So effect on the concentration, no change. Effect on the rate of reverse reaction, yes, it increases. So both the forward reaction as well as the reverse reaction will change. So the role of catalyst is just to enhance the rate of reaction. Okay. So we have discussed catalyst also, and now in the next part they'll be asking something about temperature. So let's see. Discuss the temperature also. Actually, there's another question they'll be asking about catalyst, which again, so that's why let's not rub this, because there is in the final part they'll be again asking something about the catalyst. It's a very good question. This was asked in May-June 2025 paper. All the factors, basically almost whole of the the effects of equilibrium have been discussed. So if a temperature of more than 250 degrees Celsius is used, the yield of methanol decreases. Okay. So what he is saying is that if you increase the pressure, if you increase the temperature, so this reaction takes place at 250 degrees Celsius. But what he is saying is if temperature is more than 250, the yield of methanol decreases. So basically, if you increase the temperature, if the concentration of methanol is decreasing, basically what it means is that the reaction has moved in the reverse reaction, the reverse direction. This is what is happening. And what he is saying is state what can be deduced about the forward reaction. So again, they are saying if you increase the temperature, the equilibrium shifts in the reverse direction. So what can be said about the forward reaction? Again, beautiful question, and let's try to discuss this. Let me get some space here. Okay. Now, see, if a reaction, let us assume there's some reaction which happens, x plus y, equilibrium between y plus z. So this is something which happens. Now, the nomenclature which I'll be using in this reaction is that if this is an exothermic reaction, I'll write something like this, which will say that on the right side, energy is being released. So it's basically exothermic reaction. And if this is an endothermic reaction, I will write this as minus. So this implies that in endothermic reaction, again, you'll have to have a bit of understanding of the energetics chapter also, chemical energetics also. So in endothermic reaction, basically the system, what it does is it absorbs heat from the surrounding. So that is why I'll write a sign like minus delta. This is just for your reference that in an equation, if I'm using plus delta, if I'm writing something like plus delta here, so what I'm trying to say is that this is an exothermic reaction, and if I'm writing something like minus delta here, so basically what this means is this is an endothermic reaction. Now, let us assume that there is let us assume that there is an exothermic reaction taking place. Now, in an exothermic reaction, if you increase the temperature, yeah, so the forward reaction is exothermic. If you increase the temperature, as per Le-Chatelier's principle, the system will try to decrease the temperature. How the system can decrease the temperature is, the system understands that the forward is exothermic. Yeah, so the system will shift in the backward direction. Why the system will shift in the backward direction? Because the system understands if it moves in the forward direction, more temperature will be produced. But you are increasing the temperature and system wants to oppose it. So system can only oppose it if it moves in the reverse direction. So if you look closely, this is what the question says. If a temperature of more than 250 degrees Celsius is used, the yield of methanol decreases. So yield of methanol is decreasing, which implies that because methanol is being created here, the concentration of methanol is decreasing. That implies that the equilibrium has shifted in the reverse direction. And that is why you can deduce that the forward reaction would be exothermic. So this state what can be deduced about the forward reaction. So what we can deduce is that the forward reaction is exothermic. Exothermic. So here heat would be released as a product. Heat would be released. There's one small thing that I want to clarify. So please don't get confused. Exothermic reaction we write as minus delta H, and endothermic reaction we write as plus delta H. So this remains. Please don't confuse the issues. So in exothermic reaction, basically the net energy of the system decreases. That is why it is written as minus delta H. In an endothermic reaction, the net energy of the system increases. That is why it is written as a delta H. This I have discussed in next few questions also. But this equation is definitely exothermic reaction. I hope this is making sense. And again, for your reference, I made this this note where I have captured if I have a system which in forward direction is exothermic. If you increase the temperature, shifts to reverse. If you decrease the temperature, shifts to forward. And if our equilibrium is endothermic in the forward direction, if you increase the temperature, shifts to forward, and if you decrease the temperature, it shifts to lower. And so this is about temperature, and I also captured the effect of pressure also in this Excel. So you can have a look at it, and I have also captured catalyst also. You can also have a look at it. If you find it useful, I've captured all the effects in one Excel. Okay. Now coming to the final part. So they are asking what is a suitable catalyst for the reaction? Give a reason for your answer. Now, see, for catalyst, always remember that the transition elements, they'll make the best catalyst. You will do that in, I think, periodic table chapter. There's a question which is asked again and again. So transition elements they'll make the best catalyst. So that is what is mentioned here. Copper is a transition metal which can absorb, providing an alternative reaction path with lower activation energy, thus increasing the rate of reaction. So again, this comes from rate of reaction. Catalyst is discussed in the rate of reaction chapter also. So copper is the correct answer. Let's move to the next question. So I made it intentionally a longer lot of discussion because this will sort of this was a sort of numerical where lot of concepts were being used. So let's move to the next question. Let's have a look at the next question. Ethanoic acid is manufactured in the reaction between methanol and carbon monoxide. So we want to manufacture ethanoic acid. An equilibrium is produced. So the first question is about characteristics of equilibrium. And both a high yield of ethanoic acid and high rate of reaction are needed. Reaction is carried out at 300 degrees Celsius, and forward reaction is exothermic. So heat is produced in this reaction. So it's an exothermic reaction. Now let's one by one start looking at the different parts. So two characteristics of the equilibrium, we have discussed this before. So see, there are there's a fundamental thing that you need to understand about equilibrium is that in the textbook also they write something like it's a dynamic. They write it as dynamic equilibrium. What it means by a dynamic equilibrium is it is not as if the reaction has stopped. It's just that the forward reaction, the rate of the forward reaction is equal to the rate of the backward reaction, and the concentrations of all the products and the reactants are same. Equilibrium is reached. There's a forward reaction also taking place. There's a backward reaction also taking place. It's not a static situation. It's a dynamic situation. So concentration of reactant and product remain constant, but the reaction does not stop, and that is why it is called dynamic equilibrium. Hope this is making sense. So it's not a static thing. Forward and reverse are happening, but both are happening at the same rate. So it is, just to take an example. So for example, you have a situation like this where, for example, at a railway station, the number of passengers who are entering and the number of people who are leaving on trains is equal. So during the day, you'll have a stream of passengers which will be coming, and during the day there will be a stream of passengers which will be leaving. Yeah. So it's not a static situation. It's a dynamic situation. And another important part of equilibrium definition is that the reaction must be reversible and it must be a closed system. Must be a closed system. No matter can enter or leave the system. So closed system, matter can't be exchanged with the surroundings. Energy can be. So matter cannot enter or leave, but energy can be exchanged. So for example, sealed flask with reaction, equilibrium reaction vessel. So these are the example of closed system. Okay. So this is what we have answered about the two characteristics of equilibrium. And we have discussed in detail about the equilibrium. The answer you can write it as 1. It's a closed system. And second, you can write it's a dynamic. It's a dynamic condition, not a static condition. You may also mention concentration remain constant, or you can also mention that the rate of the forward reaction is equal to rate of the reverse reaction. So we have discussed 3-4 features. You can write 2. So we have understood that this is an exothermic reaction. State the disadvantage of using a temperature below 300 degrees Celsius. Now, if we use a temperature which is below 300 degrees Celsius, now see what will start happening is that if I decrease the temperature, it's an exothermic reaction. As per Lee-Chatelier principle, if I decrease the temperature, as per Lee-Chatelier principle, if I try to decrease the temperature, the reaction will shift in a condition where it will try to oppose this decrease of temperature by increasing the temperature. So, of course, if I decrease the temperature, because it's an exothermic reaction, on decreasing the temperature, the forward reaction will increase. As per Lee-Chatelier, if I decrease the temperature, the reaction will move in a direction which will try to oppose the decrease in temperature by increasing the temperature. That can only happen if we have an exothermic reaction going in the forward reaction. So as per Lee-Chatelier, low temperature should be preferred. But what happens is if I go below 300 degrees Celsius, my rate of reaction decreases. As you would have studied in rate of reaction chapter. At a lower temperature, the rate of reaction decreases. But then what happens? If I increase the temperature above 300 degrees Celsius? Now, as I have told you, if I increase the temperature, the reaction will try to oppose this. If I increase the temperature, the reaction will try to oppose this. How can this oppose it? It can oppose it by moving in a direction where the temperature is decreased. We understand because this is in the forward direction, it's an exothermic reaction. In the backward direction, this will be an endothermic reaction. So what happens when I increase the temperature is the reaction will move in the backward direction, because when it moves in the backward direction, the temperature will get lowered. So that is why the yield will be less. of ethanoic acid that we are trying to manufacture. As discussed earlier, we had in the previous question also we had discussed this, that what is the effect, increase of temperature, decrease of pressure when the forward reaction is exothermic, when the forward reaction is endothermic. We had discussed this here, so you can refer to this again and again. The same kind of questions would. Okay, now we are saying about catalysts. What happens when catalyst is added to the equilibrium concentration? See, the concentration won't change. The concentration of the product won't change. It is only the effect on the rate of forward reaction will increase. Basically, the equilibrium will be reached faster. This is the only effect the catalyst have. The catalyst won't have any effect on the concentration. Just that the equilibrium will reach faster. The rate of forward reaction and the rate of reverse reaction will increase. Now, if the pressure is increased, as I have told you earlier, if whenever a question is being asked about pressure, you should always look at the number of moles. So there are 2 moles of reactants. 2 moles of reactants, and we are forming 1 mole of product. We are forming 1 mole of product. Now, in these kind of reactions, this is what is happening. In these kind of reaction, when you increase the pressure, when you are increasing the pressure, as per Chatelier says the system will move in a direction where increasing the pressure, the system will move in a direction where lower pressure is formed. When is lower pressure formed? Lower pressure is formed when you are moving in the forward direction. So the equilibrium concentration of acetic acid will increase. What is the effect on the rate of forward reaction? Of course, increase in pressure leads to increase in the rate of reaction. So the rate of forward reaction will also increase. So answer for both increase. Which element from the list is suitable catalyst for the reaction? Remember that transition elements are the best catalyst. So here we have what as the right answer, and because transition elements, they make the best catalysts. And also write something like this: absorb gases, providing an alternative reaction pathway with lower activation energy, thus increasing the rate of reaction. So, and write something about the rule of the catalyst also. So now let's move to the next question. This is the MCQ that I have taken. So reaction between ammonia and oxygen is shown. Again, this is a exothermic reaction. Remember, when delta H is negative, it's an exothermic reaction. This is again from a rate of reaction chapter. So when delta H is negative, this is an exothermic reaction. Heat is liberated. When delta H is positive, it's an endothermic reaction. Heat is absorbed from the surrounding. Now, regarding the temperature, because it's an exothermic reaction, if we decrease the temperature, the system will try to oppose this decrease of temperature by moving in a direction where the temperature should increase. And that is why the forward would be better, because we want to move the position to the right. We want to move the equilibrium to the right, that is in the forward direction. So decreasing the temperature would be a better option. But then they also want to discuss the pressure. Now, for always, as I have told you, for discussing pressure, please refer to the number of moles. Now, if you look at the forward direction, if you increase the pressure, the system will move. The system will try to oppose this by moving in a direction where number of moles are decreased. The system will move. If you increase the pressure, system will try to oppose by moving in a direction where lower number of moles are formed. So it will move in a backward direction. But you want to shift the position to the right. So if you decrease the pressure, now the system will try to oppose it by going in a direction where the number of moles increase, and that is a forward direction to the right. So D is the correct answer. Now let's move to the next question where structure of carbon chloride is being discussed. So let's look at the next question. Carbonyl chloride COCl2 is manufactured by reacting carbon monoxide with chlorine. So this is the equilibrium reaction that we have. Delta H is negative. Delta H is energy that is released. Energy that is released from the system. Now, because it's released from the system, one way of looking at it is the system loses energy. So this is an exothermic reaction. Whenever you see delta H to be negative, it is always exothermic reaction. Whenever delta H is positive, basically what it means is that the system has gained energy. The net energy is gained. So this would be endothermic reaction, endothermic reaction. So remember, whenever you see delta H to be negative, whenever you see, actually I've written it here. So whenever you see delta H to be negative, that means that net energy has left the system. And whenever delta H is positive, it means net energy has entered the system. And that's an endothermic reaction. You would have read this in the chemical energetics chapter. I have done a detailed lecture on that. You'll see the link of the lecture in the comment section or in the description box. Do have a look at that. So delta H is negative implies this is an exothermic reaction. Now let's look at the question. The process takes place in a closed system, okay, and equilibrium is reached. The condition for the process is 200 degrees Celsius and 200 kilopascals, okay. To explain what is meant by a closed system. Now, I have done a detailed analysis. I'll spend some time on it just to give you an idea. So open systems are systems where both matter and energy can be exchanged with the surroundings. So for example, if this is an open system, matter can enter and leave the system as well as energy can enter and leave the system. So it's an open system. So basically reaction in an open beaker, boiling water in an open pan. So these are the examples of open system. The second type of systems are closed systems. In closed systems, what can happen is you can't exchange matter. You can't exchange matter. Matter can't be exchanged. Matter can't be exchanged between the system and the surroundings. But energy can be exchanged with the system and the surroundings. So matter cannot enter or leave, but energy can be exchanged. So basically, sealed flask with a reaction, or typically when we say equilibrium or when we say reversible reactions, they always take part in the closed system. There is another system which is known as isolated system. In an isolated system, neither the matter nor energy can be exchanged between the system and the surroundings. So thermos flask, an ideal thermos flask, insulated bomb calorimeter. This calorimeter, in the physics portion, in the heat portion, you will either have read this or you will read in the bomb calorimeter. I'm not going into the detail of this, but this is part of the heat chapter in physics, thermodynamics physics part. And there is another system which is called adiabatic system. Either your teacher would have discussed this in class or you will discuss this in detail in the grade 11. Now here work can be done on the system. So it's a perfect insulated system. You don't need to focus much on adiabatic system. I just wanted to complete the list, so that is why I discussed. But for us, the important thing is that whenever we are discussing equilibrium reactions, reversible reaction, the important condition is that they can only take part in the closed system. Matter can't be exchanged with the surroundings. System and surroundings can't exchange matter. So the first question which was asked is what is meant by a closed system. So closed system I have discussed in detail, but these are the notes which I have prepared. Would be there in the PDF, in PDF form in the description section. The closed system is one in which no matter can enter or leave, although heat can be exchanged with the surroundings. Closed system is one where no substances can enter or leave. So second question, what does delta H represent? Basically, this is the technical definition is enthalpy. But again, in grade 10, they don't use the word enthalpy. We write it as heat energy only. So basically, delta H is the net energy that system either gains or loses. So here, delta H is negative. It's an exothermic reaction. Delta H represents the energy exchange. Okay, and see, I have also mentioned here why does a equilibrium require a closed system? state how the value of delta shows that the forward reaction is exothermic. We have discussed this. And one thing that I wanted to just mention, I won't be discussing this in detail, is why do we require equilibrium to be in a closed system? See, a very simple definition is, look at this reaction. I won't be spending much time. I just wanted to give you an idea. If matter can leave or enter, so for example, if you add COCl2 or you let Cl2 leave the container, the system, then you will shift the equilibrium as per Le-Chatelier principle. So that is why equilibrium can only be reached in closed systems. I hope it's making sense. So next question, reduce the value of delta H for the reverse reaction. Again, what you need to remember is that if we reverse this reaction, this will become an endothermic reaction. So basically, what I'm trying to say is that if you have COCl2 gives CO plus Cl2, then this is a reverse reaction and this becomes an endothermic reaction. And hence, the delta H would be positive 105 kilo per mole. Okay, so now we are discussing the effects. Now, see, discussed many times before, exothermic reaction. If the temperature is increased, one thing that I'll advise is you have to carefully see effect of concentration of CO2. You have to carefully see on which element of the reaction, which compound are they focusing on. So here they are focusing on the product. Remember this. Now let's start. Now if temperature is increased, the system will try to move in a direction where the concentration of COCl2, the concentration of COCl2 decreases. Why? In the forward reaction, anyways, due to exothermic, the temperature is increasing. Now, if you increase the temperature as per Le-Chatelier principle, the system will shift in a direction where the temperature should decrease. The temperature would decrease in the reverse direction. So the concentration of COCl2 will decrease. Hope this is making sense. Some CO is added. Now, that is what I was saying, that you need to have a closed system. So for example, in this case, if you add CO, you are increasing the concentration. Now, as per Le-Chatelier, if you are increasing the concentration of CO, the system will move in a direction where the concentration of CO should decrease. That can only happen when you move in the forward direction. Consequently, COCl2 will increase. The concentration will. Pressure is increased. As we have discussed before in the previous question also, whenever they are asking you question regarding the pressure, always look at the number of moles. So on the left side, 2 moles. On the right side, 1 mole. Now, if pressure is increased, the system has to move in a direction where the moles, the system has to move in a direction which opposes this increase of pressure. Which opposes, I'll write it here. If you increase the pressure, system has to move which opposes increase of pressure. How will the increase of pressure be opposed? You will have to decrease the pressure. To decrease the pressure, the number of moles should be more. Number of moles which are made should be less. That can only happen in the forward direction. And COCl2 concentration will increase. So by increasing the pressure, you are actually manufacturing more carbonyl chloride. So the concentration of COCl2 will increase. Hope this is making sense. Now, a catalyst has no effect on the concentration. It just has the effect on the rate of reaction. Always remember this. The equilibrium is reached quickly. That's it. No effect on the concentration of either the products or the reactants. So next question, nitrogen monoxide, O2 react to form nitrogen dioxide, room temperature, reaction can equilibrium. Okay. Delta H is negative, so it's exothermic reaction. Passed into a beaker. This is a beaker. Now, as you can see, this is a excellent question to understand what we were discussing in the last question. So in the last question, we were discussing about the closed system, open system, and the definitions, etc. Now, if you look closely, this is an open system. This is an open system. Why? Because if I represent system as like this is the system and these are the surroundings. So this is how we show system. Basically what we do is we put a boundary. I'll make this again. So this is a system and the rest of the world is the surroundings. Now if you look, this is a open system because matter can be exchanged with the surroundings as well as energy can be exchanged from the surroundings. So it's an open system. So that is why we can't have an equilibrium state in this. So explain why a method does not allow the reaction to reach equilibrium, because the energy exchange is okay, but you can't have matter exchange. And why you can't have a matter exchange? Again, due to Lee-Chatelier principle, that say for example, because it's an open system, as oxygen gets used, more and more oxygen is available from the environment. So as more and more oxygen is available from the environment, the reaction will always keep moving in the forward direction. See, what Lee-Chatelier is trying to say is that the equilibrium, in a state of equilibrium, if you increase the reactant, the concentration of the reactant, the equilibrium will shift in a direction which will try to decrease the concentration of the reactant. But here the concentration of reactant keeps on increasing. So how will it reach equilibrium? So I hope this is making sense. So the only way you can make this reach a equilibrium position is if you close this. So once you have put the NO and the O2 in the system, then you close the system. Then you close the lid. Now matter can't be exchanged, but the energy can be exchanged with the surroundings. So only then you will have a equilibrium state, a dynamic equilibrium state. Hope this is making sense. So in the previous question, I discussed this open system, matter as well as energy is exchanged. Closed system, matter is not exchanged, but energy can be exchanged. Isolated system, neither matter nor energy can be exchanged. So this is an example of an ideal thermos flask. There is something called an adiabatic system also, not in your syllabus, but I just mentioned it here. If anyone is interested, you can have a look at adiabatic system. On ChatGPT, you can have a look if you are interested. This is usually explained in detail in class 11. So explain why we have done this. Apparatus is changed, equilibrium is reached. Okay. So temperature is then increased, position of equilibrium shift to the left. Okay. Now let's try to understand. So now when the temperature is increased, the system wants to oppose the increase in temperature. How the system will try to oppose the increase in temperature is shifting towards a reaction which is endothermic. It will try to reduce the temperature. So if the equilibrium shifts to the left, that implies that on the left you have endothermic, and therefore you can deduce that the forward reaction will be an exothermic reaction. So explain why the position of equilibrium shifts to the left. It shifts to the left because the forward reaction is exothermic. Explain why the position of equilibrium shifts to the left. As we have discussed, basically, again and again, the core principle on which whole of this chapter hangs by is the Lee-Chatelier principle. You should be very clear about Lee-Chatelier principle. I have discussed this before in the previous questions also. So basically, when a change is made to the conditions of the system in a dynamic equilibrium, the system moves so as to oppose that change. We basically took an example of teenager and a parent. So whatever the parent will say, the teenager will try to oppose it. If the parent says play, the teenager will start studying. And if the parent says you have to study, the teenager will start playing. So a rough example to understand how Lee-Chatelier principle is put in action. So you should be very clear about Lee-Chatelier principle. Try to get as thorough as possible about this concept of Lee-Chatelier. And that is why the more and more questions you do, previous year question papers you do, the more you'll understand. The next question is pressure of the equilibrium system is then increased. Now, if you look at the reaction, you have 3 moles of reactants and 2 moles of products. So when you increase the pressure, it will move in a direction which will try to. So if you increase the pressure, the equilibrium basically wants to oppose this increase of pressure. It wants to decrease the pressure. How will it decrease the pressure? By moving in the forward direction, by shifting the equilibrium to the right, because from 3 moles you are coming to the condition, to the situation of 2 moles. So the reaction will move in the forward direction to oppose this increase. Okay, there's another small question I wanted to discuss. This involves, again, this is a very interesting question. This plays on oxidation numbers also. I hope you are thorough with oxidation number. If you are not, I'll put the link of one of my oxidation videos in the notes. You can have a look at that. So in this case, we are very sure that whenever chlorine is in the free state, the oxidation number would be 0. That is what I have written here. And whenever chlorine is in combined state, it is in combined state XCl, XCl2, the oxidation will be -1. So for halogens, the oxidation number would be -1. So here if you see S2Cl2, here Cl has oxidation number of -1. Sulfur has an oxidation number of +1. I won't be going into the details of calculating the oxidation number. I'm assuming that you know oxidation number. Here it is 0. Here chlorine remains -1 and sulfur becomes +2. So in this case, sulfur is going from +1 to +2 in the forward direction. Forward chlorine, in the reverse direction, if you look closely, chlorine goes from -1 to 0. If you look closely, -1 to 0. So the question is, sulfur is oxidized in the forward direction? Yes, of course, because it goes from +1 to +2. This is what we discussed right now. Chlorine is oxidized in the reverse reaction. Yes, it is oxidized because it goes from -1 to. Hope this makes sense. So now let's move to the next question. Hydrogen iodide thermally decomposes into iodine and hydrogen. Reaction is reversible. This is a reversible reaction which is given. Show gas iodide syringe sealed mixed is heated to 10 degrees Celsius. Mixture of gases reaches equilibrium and is purple. So when this equilibrium is reached, the mixture of gases, it turns purple. Now, before I start the question, there's an interesting thing that you'll see that on the left hand side, we are dealing with 2 moles. On the right hand side, again, we are dealing with 2 moles. Now, this becomes interesting. If you have seen the previous questions which I'm doing in this PYQs, in all the previous questions that we had seen, the number of moles on both sides differ. So 3 moles, 2 moles. Say here we have 2 moles, 1 moles, 2 moles, 1 mole. So in all the previous questions that we had discussed, the number of moles on the left hand side and the right hand side are different. But in this equation, the number of moles on both sides are same. Now the situation will become very interesting when they will play with the pressure. So I hope you are understanding. If you're not, we'll just discuss in few minutes. So that is why it's a very interesting question. The number of moles on both sides are same, and then they will make you discuss that what happens when you change the pressure. So anyways, the first part of the question is what is meant by the term equilibrium. So you can refer to your textbook and answer this question. I have made these notes. You can refer to this definition also. So chemical equilibrium is a state of reversible reaction in a closed system where the forward and reverse occur at the equal rate. So the concentration of reactants and product remain constant. So see, the beauty of definitions is that you try to capture everything about the equation in that definition. So it's a reversible reaction. It's a closed system. Forward and reverse rate of reactions are equal. Concentration of reactants and product remain constant. So everything is being captured. And you can also mention the conditions required for equilibrium. A reaction must be reversible, must take in closed system, which anyways you have put in the definition. So what I always advise my students is to write the textbook definition. There are few definitions that you need to cram, and because a teacher is looking for specific words in your definition, you shouldn't be writing vague answers. Otherwise, you won't get the due credit. So this part is clear. The pressure of the mixture is increased. Now you'll understand what I was saying in the beginning of the question. Now the pressure is increased. All conditions remains state the same. The position of equilibrium does not change. Of course, the position won't change because see, in a typical reaction where the left hand side is not equal to right hand side. So, for example, if we had taken a equation like this, here if I play with the pressure, if I increase the pressure or if I decrease the pressure, there will be a shift in the forward and the backward. The equilibrium will shift in the backward and the forward direction because the number of moles on left hand side and the right hand side are different. But in this equation, how will the pressure affect? So the position of equilibrium does not change. Yeah, absolutely. So pressure won't be able to change the equilibrium. But then here comes the interesting part. The color of the gaseous mixture turns darker purple. It was purple initially, but now it has turned darker purple. So the temperature remains constant. Temperature you have kept constant. Explain why the position of equilibrium does not change. So the equilibrium does not change because what Chatelier has said is that, say for example, if you increase the pressure, the reaction will try to, the equilibrium will try to shift in a direction which will try to oppose this. But then how can the system oppose increase or decrease of pressure? Because the number of moles on both sides are same. So as per Chatelier, because the number of moles on left and right are same, the equilibrium won't get disturbed even if you play with the pressure, you increase or decrease the pressure. So that is why the position of equilibrium does not change. Okay? Now the interesting question is, suggest why the color of mixture of gases turns darker purple. So what exactly does happen? See, now you need to understand is that once you have increased the pressure, though the equilibrium has not shifted, but the volume of the gas, the volume of the product is being confined to a lesser volume. So as to say, so for example, just to take an example, so let us say that initially the mixture of gases reaches equilibrium and is purple. So in the initial equilibrium condition, when it was purple, let us assume that the volume of the gas was 1 liter. Now you increase the pressure, you bring the volume of the gas to 0.5 liter. So the 0.5 liter, the purple color is now confined to 0.5 liter. So that is why it will seem darker. So what I'm trying to say is that increasing pressure compresses the gas, the concentration of all the gases increases. So the amount of iodine remains unchanged, but now it is confined to smaller volume, and that is why the color seems darker because of the gas is being confined to a lower volume. Specifically, what you can write is increasing pressure increases the concentration of iodine gas, making the purple color darker. And for the first part, when we said the position of equilibrium does not change, so as I discussed, left side, right hand, both are 2 moles. Number of moles is the same on both sides of the equation, so changing the pressure does not shift the equilibrium. So I hope this is making sense. This is a very interesting question I found. Different from the usual questions that they ask. Because in usual question, the number of moles on the both sides are different. So it becomes a very hackneyed question. This specific question was asked in 2024. Next part is the temperature of the gas is decreased. All the conditions are the same. The mixture of turns lighter purple. So it becomes lighter purple. Basically, lighter purple state whether it can be deduced that the forward reaction. What can be deduced about the forward reaction from this information? So temperature is decreased. Let's discuss this. See, temperature is decreased. Write it here. Temperature is decreased. The light purple it becomes. Light purple. Which means because the forward reaction is purple and on the left side it is colorless. So the reaction would have shifted to the backward direction. Because more amount of colorless gas would have been made, and that is why the purple lost its color, like it became lighter purple. Now you are increasing the you are decreasing the temperature. Now, as per Lee-Chatelier, the system will try to increase the temperature. So the system understands that if it reverses the direction, then the temperature can be increased. So this direction would be exothermic, which implies that the forward reaction would be endothermic. If the reverse is exo, then the forward would be endo. If the forward is exo, then the reverse would be endo. So what we can deduce is that if temperature is decreased, the forward reaction is endothermic. I hope you have understood the discussion. The temperature is decreased or conditions, the mixture becomes lighter purple as to the left. So applying Lee-Chatelier's principle, decreasing favors the exothermic reaction. So from I2, reverse must be exothermic, therefore forward must be endothermic, therefore the forward is endothermic. So I'll be attaching the PDF in the link of the PDF in the description. So please refer to that. So this was an interesting question. Hope found it interesting. Now let's go to the next question where we discuss this reaction again. So in the next question, a carboxylic acid reacts with alcohol to produce ester and water. Under certain conditions, this reaction can be reversed. So an ester reacts with water to produce carboxylic acid and alcohol. Now this is a pretty famous equation. You would have studied this in organic chapter, or you will study this in organic chapter. So now we have an equilibrium equation, and the equilibrium is written like this for this particular case. Ester plus water gives acid plus alcohol. The forward reaction is endothermic. So remember that if the forward reaction is endothermic, the reverse reaction will be exothermic. If the forward was exothermic, the reverse would be endothermic. So now they are asking, what is the endothermic reaction? Endothermic reaction is a reaction where the heat is absorbed from the surroundings. So net heat is positive. So this is written as delta H is positive. In chemical energetics chapter, you would have studied this. So delta H is positive in this. In exothermic reaction, delta H is negative. So for example, in this case, delta H would be positive for the forward reaction because it's an endothermic reaction. There are questions where they also ask you the sign of the, or they will ask you the about the exothermic reaction. What is the sign? So because the reverse reaction is exothermic, so this will have a negative sign. So the forward reaction is endothermic, delta H is positive. The reverse reaction is exothermic, delta H is negative. This is a reverse reaction. So I hope this is clear. So complete the table to show the effect for each condition. So the first condition is, I will rub all this, so get confused. Okay. So temperature is decreased. Now, if you decrease the temperature, the system will try to increase the temperature. It can only increase the temperature if it moves in the reverse direction. But if it moves in the reverse reaction, they are asking the effect of concentration on carboxylic acid X at equilibrium. So they are asking about this X. But if it moves in the reverse direction, the concentration of X will decrease. That is why this decrease. Concentration of ester is decreased. So this ester, this is the ester. So if you decrease the concentration of ester, the system, as per Lee-Chatelier's principle, it will try to increase the concentration. It will try to oppose the change that you are bringing. So it can oppose the change by increasing the concentration of ester, and that can only happen if X is consumed. So that is why the concentration of X would decrease. I hope this is making sense. More alcohol is added. So if you add more alcohol, you add more alcohol, then what you will see is the alcohol Y is added. Because as per Le-Chatelier's principle, it will try to oppose this. How will it oppose this? You are increasing the amount of alcohol. System wants to decrease it. How it can decrease it? By making sure that the reaction moves in the reverse direction. And when it moves in the reverse direction, the concentration of carboxylic acid decreases because the reaction has moved in the reverse direction. A catalyst is added. Now, this is a very typical question which is asked again and again. So, see, the catalyst just brings the equilibrium faster. It doesn't affect the concentration of the reactants and the products at equilibrium. It doesn't affect that. So I hope this was also you understood this. So with that, we have come to the end of these general equations. This is a repeat question. I realize this now. So we have solved a good number of general equilibrium based questions. You see, we would have done at least 7 to 8 questions. And I can assure you, if you have studied this lecture, understood the concepts well, then in the board exam, you won't face any difficulty when you are doing these equilibrium reversible equations. In the next part, what we will do is, I'll be taking questions based on the manufacture of sulfur and ammonia. So we will be doing these questions based on, first we will do sulfur questions. I'll be referring to this sheet. This captures both the process, basically it captures both the process on the same sheet. So we will be doing contact process first, then we will move to Haber process. And these are again the questions which I am taking are from the previous year question papers from 23, from 24, 25. So I hope you will look at the part 2 and part 3 of the lectures also. I'll mention the links below. So we have a lot of questions that we'll be doing, and hope the series is being. Thanks a lot for watching.